All right. Thank you very much, Larry. And thank you to all of you out there who are attending today. Quick apology for extreme close-up that you might have gotten on the invitation that went out. Apologize for some of you getting scared by that. Please hold while I mute. I gotta mute somebody here. There we go. Getting some background noise, so I just need to make sure everybody's microphones are on mute, please, and then afterwards we'll open it up for questions at the end. Yeah, it keeps getting unmuted for some reason. But today I'm going to talk to you about soil stabilization and full depth reclamation using a product called Cement Slurry. The basic principle of full depth reclamation is it's a way to rebuild worn out asphalt pavements, flexible pavements, by recycling the existing roadway and preserving the original roadway investment. So you're basically reusing it and reintegrating it into the base material. The old asphalt road is 100% recyclable, and there's no need to haul off 100% of old failed asphalt because it can be recycled and put right back into the road bed. This process saves money and builds long-lasting roads. The other thing that's awesome about it, especially from a ready mix producer standpoint, is that we are in the business of concrete and ready mix concrete. And for ready mix producers, this opens up a whole new line of business where we can be involved with all road building, even if it's an asphalt road, we can still be a part of the road building process just by our efforts in the base and stiffening the base. So we're going to get into that in more detail as we move on. This is just a brief example of what a road looks like that we did FDR on. So this was what it looked like the day I showed up. In this example, we have a county road that basically we had a residential subdivision getting built not too far from this picture. So all the materials, all the vehicles delivering the raw materials, heavy duty trucks, were using this road, to get in and out of the subdivision, just totally tore the road up. So the city of Westfield decided, hey, why don't we use FDR in this application rather than completely tear out this road or do a mill and fill to try to rebuild it. This is what it looked like after the full depth reclamation process. What you can't see here is all the broken up pieces of asphalt because they're actually mixed into the base along with cement slurry. And then the final product, after it got paved, it's got asphalt over the top of it. I think two different lifts, an intermediate lift and a surface lift. But that's sitting on a very stiff layer of treated subgrade. Full depth reclamation is most appropriate under these conditions. So if the pavement is seriously damaged and just can't be mill and filled or rehabbed with a resurface. If the existing pavement distress indicates that the problem lies in the base or subgrade, in many cases, whenever we're dealing with moisture related problems, that's oftentimes the case where moisture has gotten beneath the pavement and softened the subgrade soils. Or if, like in the example I just showed you, the pavement structure is inadequate for the current or future traffic, obviously that old county road couldn't stand up to all the construction traffic that it was enduring because of all the development that was happening there. Or if let's say that there is a mill and fill type of a job where a job is getting resurfaced, If the entire surface area requires 20% or more undercutting or full depth patching, then if you put a pencil to it, you may be able to do full depth reclamation on the entire surface area of that parking lot. Then you have a uniform base, and you can even value engineer your pavement design. The state of Indiana has specs for full depth reclamation. If you look in the current spec book 307-R-657, you will find the spec for FDR. And within that spec, you can read that cement slurry may be applied as long as it has a minimum dry solids content of 60%, which it does. Also, you'll notice that cement is widely used in airport specifications. I've got them listed here, all the different airport specs where cement slurry can come into play, and we have done a fair amount of airport work, which I'll show you some case studies later. But cement is the key ingredient. Cement is what makes it work, because the cement is the glue essentially that bonds all the particles together. If you look at this close-up picture, you can see all the particles of aggregate. You can see the dark black, which obviously is pieces of recycled and reclaimed asphalt. But then you see the more brownish matter in between, which is the subgrade soils. And the fact that that all the particles were treated with cement slurry, it basically reacted like a glue to bond it all together. So that's ultimately what we're talking about here. FDR is keys to success. I'm not going to read them to you, but I am going to get into each one of those in a little bit more detail. So first of all, your site should be investigated to determine the original cause of failure. As mentioned before, a lot of times moisture can be the problem, or improper drainage on a road. Cores or test pits can be taken from the job site or from the road to determine how thick is the existing asphalt, and also to gather samples to take back to the lab. That's where lab testing can be performed. We'll talk a little bit more about some of the lab testing. What they do there is typically a gradation, a Proctor test, which is where they determine the maximum dry density and the optimum moisture. And they also mold specimens to do unconfined compressive strength testing. If you look here, this is also an excerpt from the NDOT spec book, but you can see that during the pulverization phase of the job, they're looking to get a combined gradation of material that has 100% passing the 2-inch sieve and 55% passing the number 4 sieve. So what I like to tell people in a very generic sense, if you think about the materials that go into cement slurry, you have cement and water, also a hydration stabilizer, which is just for retarding the cement. But if you've got cement, water, 100% passing the 2, which is basically your coarse aggregate, and 55% passing the number 4 sieve. Basically, you've got coarse aggregate, fine aggregate, cement, and water. You mix those things up. Those are your 4 main ingredients to make concrete. Okay, so essentially what we're doing is we're mixing a very like a field grade version of concrete on the spot in place. So in the lab, we determine the maximum dry density and optimum moisture. That information is used in the field during compaction. Also in the lab, you can mix the specimens together to get essentially 95% optimum moisture or maximum dry density. And you want to mold those specimens together to where you can make pills and then break those for unconfined compressive strength. And NDOT does have requirements for the strengths. If you look here in the notes section of this slide, you can see that 300 PSI is the minimum unconfined strength whenever an HMA overlay is going to be placed over the FDR. that is greater than 3 inches. And if it's between 1.5 inches and 3 inches, it's 400 psi. And if it's less than 1.5 inches, it is 500 psi. So the thinner the overlay, essentially the stronger they want the FDR section to be, because that's where most of your load carrying capacity is taking place, is in the base. Thickness and application rate. This is where data from the lab testing is used in the design. Also, MEPDG design software could be used to determine the FDR thickness design and the ultimate strength needed. This is an example of a job that we got to work on for the city of Indianapolis. The standard specification for the job was to remove the existing asphalt and replace it, and just remove what was there. What was there was 1.5 inches of surface, 2.5 inches of binder, and 3 inches of base. So basic mill and fill. There was a lot of concern about the amount of undercutting and soft subgrade soils that would be encountered. And so we got the opportunity to talk to them about using full depth reclamation. And if you look at the standard pavement section on the left, 7 inches thick, has a total structural number of 2.35. That's using all the structural coefficients for the layer thicknesses described. So what we did was a value engineering alternate. Excuse me 1 minute, somebody's echoing pretty bad. All right, I think that's better. We did a value engineering alternate. We proposed 10 inches of FDR with treated with cement slurry. Remove asphalt base, which was 3 inches thick, and then also go ahead and, I'm sorry, remove the binder, which was 2.5 inches thick, and keep the asphalt base and the asphalt surface. So once we did that, we got that approved. We increased the structural number of the pavement by over 40%. The structural number of the pavement, it's behind another window here, but I believe it's 3.5. There's the mouse. There we go. Yeah, 3.5 structural number, and a total pavement thickness of 14.5 inches. So basically what we've done is we've increased the structural number by over 40%, doubled the thickness of the pavement, and we did it all at a cost reduction of $4.45 per square yard. The other great thing about it is the contractor and the city had to spend $0 for any fail-proof roll or base repairs that they encountered. Like, for example, on the left, once all the asphalt was milled off, they would have done a proof roll and probably determined that there was a significant amount of undercutting that needed to be done in order to fix soft spots in the subgrade. So there was none of that took place with the FDR, because the FDR attacks and treats those soft spots in place, so you don't have to worry about it. Let's talk about construction a little bit within for FDR. Now, in some cases, milling may be required, where you have to mill and remove some of your asphalt. You may not have to remove it all. You certainly don't have to remove it all, but in some cases, you might have to remove a significant portion of it, and that all depends on the final grade of the pavement that you're putting back on top. So in any case of FDR, we are going to add a new pavement over the top of the FDR treated base. So that is we are adding material to the jobs, to the pavement. Okay, so it is going to raise the grade. So if the grade needs to remain exactly the same as when you started, then you will have to mill and remove some in order to make that work. In the case of some county roads that we've done, like this one, for example, it's okay to raise the grade. In fact, raising the grade promotes better drainage to get the water to shed off the road towards the ditches. So that's certainly a win-win for a county road or any pavement where you can raise the grade on. It could be a parking lot as well. But the initial phase is the pulverization, and basically all you're doing there is turning the old asphalt into aggregate. Okay, and we talked about the gradation that we're looking for, and we're really just doing this deep enough to get through the asphalt. Okay. Going to pause that real quick because there is volume on that video, but in this case, this was a job up in Tipton County where it was just a chip seal surface, and the motor grader was able to just drop its knives in the rear and just run through that and chew it up. Okay, so we found that was going to give us a gradation that was working really well, because by the time we applied slurry to that and the stabilizer ran over it, it was producing a really nice gradation coming out the back. So I'll let this continue playing. In the NDOT spec, you will also notice there's language about corrective aggregate. Corrective aggregate is only needed if the gradation is not acceptable prior to adding the cement slurry. So here you can see that sand was added in order to basically add more fines to the total gradation. This is seldom needed, but it is something that's needed sometimes. This is kind of a look inside of a reclaimer. The reclaimer is really the tool that makes this whole process work the way it does, is because it's the mixing efforts that drum creates. So once all the once this drum passes through, you're getting a really nice mixture of all the materials that it's going over. And there's different types of them. Wirtgen is a very popular model. Roadtech makes one, and Bomag, just to name a few of them. There's probably others that I've forgotten, but those are the main three that I've worked around in my career. Moisture control is very important, to have the right moisture. I showed you the slide earlier of the maximum dry density and optimum moisture. It is a compactable material, so the purpose of doing the Proctor test is to determine at what moisture can we get the best compaction possible. And so in some cases, depending upon the nature of the subgrade that you're treating, it may be necessary to pre-wet the subgrade prior to any slurry going on it, just to make sure that you have the proper amount of moisture in the mix to get good compaction. Also, you don't want to have such a dry mix that the cement that you're applying is starving out for water. Now, the cement slurry is made with water, yes, but it's really only enough water to wet the cement and to promote hydration. Now, cement loves water, so the water that it gets from the subgrade is going to help aid in strength gain and strength development from that cement. Now let's talk about the application of the cement. Okay, so there's a couple different ways that it can be done. The dry method, which was the method that was widely used prior to my company ever getting involved with cement slurry. And I got some pictures of that. Now, there are some negatives that come with the dry method, especially if the contractor is not, perhaps doesn't have the right kind of dust collection equipment on his machinery. But this is a picture of a dry placement where you can see motorists are driving down 465 through clouds of dust with limited visibility. So this is an extremely dangerous situation that I would think would want to be prevented. Here's a job that we were involved with on I-69 up near Pendleton, Indiana, and you can see that ultimately the same type of chemicals going down on the subgrade, but you don't see any dust, and that's because all of the cement is made in a slurry form so that it can be applied. Slurry is cleaner and safer and provides no visual obstructions. And it's 100% dust free. It's also approved for soil stabilization, chemical modification, and full depth reclamation. Now, I want to mention that too, because I've talked quite a bit about full depth reclamation and recycling of asphalt, but cement slurry can also be used for soil stabilization. So that's also an NDOT specified operation. Here you can see a dry dusty placement where dry chemical was being applied to the subgrade. This road is open to traffic, and this is in a residential subdivision. Same type of situation here on the interstate. Here's another dry dusty application out at the airport, Indianapolis International Airport, where right next to where this picture was taken, there was a dry chemical operation being performed. So I would think this would be a big problem to the folks that are out there at the airport. So our solution obviously is cement slurry, making and delivering and placing the cement slurry with a ready mix truck. Ready mix trucks are all-wheel drive. They can get through most types of terrain, and I'm sure the pilot up there can appreciate not having to fly his airplane through a dust cloud to try to land that sucker. It's another picture from a different angle out of Indianapolis International. This was a temporary road that we put in with Milestone contractors out at the airport. So what you're seeing there is a drop spreader, basically dropping the dry chemical out on a subgrade. You saw the way the wind was blowing was pushing the dust right into a residential subdivision and also a daycare. And in that daycare, we were told that they had to pretty much shut down, obviously limit the kids' exposure to going outside, and then shut off their HVAC system because it was pulling into the building. Applications like this, should be a slurry method so that you don't have to deal with those types of problems. I don't know why this photo looks the way it does, but this is a slurry placement that we did at right outside of a daycare, and we had kids on the other side of the fence there watching us. In certain specifications that NDOT has written, the use of cement slurry has been specified, and I think NDOT has recognized that this is the way to go for certain jobs, because obviously the dust method, they can't have situations like they had in some of the photos I showed you. So since we've come up with the slurry method, it's been specified to try to prevent the problems ahead of hand. And you can see cement slurry only. They've actually struck out the words can be used as dry or as a slurry. It's as a slurry only. So there are certain contracts out there where they have recognized that, hey, slurry is the way to go. This is what we want. And I got to believe that this is going to happen more and more frequently. This was the first NDOT job that I was ever a part of. This was way back when I worked for Builders Concrete, but this was Keystone at the crossing, Keystone Avenue, just south of 465. All of the subgrade that we did there got treated with cement slurry. And you can see that we've got a truck in the background dispensing cement slurry. Now, if that were dust placement, you'd have dust all over those cars that are for sale right there. So I think that was one of the main reasons why the DOT elected to use, and the contractor, I should say, elected to use cement slurry. There is an OSHA silica law, which is basically saying that you know, there's certain amounts of silicates that should not be breathed in by individuals on job sites. So with the use of slurry, you don't have to worry about breaking that violation. There is no swell with the use of slurry. There's only a small grade change, and that's because we're adding a raw material, which is cement. It is DOT approved by NDOT. You get 100% hydration of all the cement particles. It's cost competitive to the dry placement. It provides a safer working environment, and you have the ability to add a retarder to it, which is fantastic, especially in really hot weather, because in really hot weather, you know, the cement slurry can want to take off and start setting up faster, and the ability to add the retarder allows us to basically put the set time on pause until the material gets worked into the subgrade, and then it's a time release. The retarder is a time release product that doesn't start actually gaining strength until after the materials have been compacted. So in that video, you can see the cement slurry being placed on the subgrade, just being placed obviously with the front discharge ready mix truck. It's placed in a measured amount onto the top of the subgrade, and there's just another example of it. So for example, people may ask, well, how does the driver know how much to put down or the thickness or whatever? So the way that we've been successful at it is by providing a quality control technician on the job site, and he gets there prior to the job starting, prior to the slurry placement, and he basically does field measurements, and he's marking up the subgrade with paint. You can see a few different examples here. So an entire load of cement slurry, for example, on the very bottom example, a 4% 14 might go, you know, a given width, call it 20 feet wide by however far, okay? Where if the application rate has to be 6%, maybe that same truck only does a portion of that length, maybe the same width, but not quite as long. So we have developed some calculators that our QC team works with to determine, okay, what's the specified percent, the specified depth of treatment, and the soil density. And based upon those factors and the amount of cement that we have in our ready mix trucks, we're able to exactly determine the amount of coverage area that a truckload of cement slurry is going to be able to cover. So now we're talking about the mixing portion of it. So after the cement slurry is applied to the top of the surface, then it's mixed with the road bed. Usually that's anywhere from 10 to 14 inches. After it's mixed, then initial compaction should begin, and that should begin within 30 minutes of the mixing. That's most always typically done with a vibratory pad foot roller. There you can see an example of one pictured here. Also, grading is very important. The grading comes next. That step involves additional earthwork in order to widen the roadway. It's very critical for smoothness, especially when only a chip seal is to be applied, because ultimately the way the road is going to ride and drive is ultimately dependent upon how good of a job the grader guy does. So very important step, especially when your thickness of overlay is thin. And then final compaction is done using a smooth drum roller. Compacted base can be opened immediately to light duty traffic. Now this is something that's really important to inner cities that want to do FDR, because really what they're saying is we don't have to close access to the road for the residents that live on it. So we can let the homeowner drive out of the driveway, go to work in the morning. By the time they come back home at night, this is what they're driving on, and they can drive right into their driveway. So, and usually, in urban areas, when we've done neighborhoods, it's very important to communicate with the homeowners what's going on. So oftentimes, proof roll is done at 24 hours. Sometimes it's a little longer, but most every time, 100% of the proof roll passes at 24 hours. That's assuming that the soils beneath the FDR layer are sound and not pumping or rutting. Density tests. So moisture and density can be monitored to achieve 95% compaction, as long as the moisture is between -1 and +2% of your optimum moisture. Now I want to show you a video here. This is from Structure Point. And this was a video that was taken on a job that we did, one of the largest jobs that I was ever a part of. It was 18 miles of interstate I-65 from Southport Road to Franklin, State Road 44. So take a look at the video, and it's Rod talking about some testing that he's done on cement slurry treated soils.
Good morning. My name is Juan Pizarro with American Structure Point here at the I-65 widening Wood in Franklin. What we're looking at here, material treated soil up to 14 inches with a 4% slurry, cement stabilizing. I've got my DCP right here, checking it for stiffness for industrial. The first 6 inches, we're looking for 17 blows, and then we're going to also check the 6 to 14 inch layer, and that will be a 17 blow requirement. So I'm going to commence here. I'm going to seat my blows here, get the foot settled in. By the way, this material is about approximately 24 hours old. See what we get.
This video is sped up just so that it moves along a little quicker.
Next layer, 14 inches from 6 to 14 inches. So we started at 9, so we're going to go all the way to that's 6 inches. 8 inches. at about 19 blows to get to that last 6 to 14-inch layer. So between the top, we got, what's that, I'd say 30 feet. So that's pretty good material. So we'll call it a pass.
As with any material, as time moves, cement treated material, as time moves forward, you're going to get an increase in strength over time. So you know what you just saw there was in 24 hours, and obviously over time that continues to build strength. And I think that that's why we're seeing a lot of specifications for cement treatment in new road construction, because I think that designers are seeing and owners are seeing value in putting a little bit more money into cement versus, like, say, lime treatment, because of the value that you're getting and the longevity that you're getting. It does create a very rigid subgrade. This is an example of a dozer on it in just 48 hours, and it was sanded right on top of it. Basically a treatment that we did of 53 stone that was not able to get compacted because it was too wet. After the installation, a new pavement surface can then be applied, and that could be a chip seal, conventional concrete pavement, roller compacted concrete, asphalt pavement, or a micro surface. And just an example of how FDR compares financially. What you see here in this slide is I'm not going to read each of these values off to you, but the yellow is showing full depth reclamation, where the red is showing basically a new road. So you can see that you're using less trucks, you're using less new roadway material, you're taking nothing back to the landfill in the case where you don't have to mill and remove any, and you're using a lot less diesel fuel. So when you add it all up, it's very sustainable, and it really does save a lot of money. These are actual core samples of projects that we've done, full depth reclamation with cement slurry. And also note that if you're paving over an unstabilized base versus a cement stabilized layer, that means there's less support for your layers that are going above. So rutting is more likely to occur in an unstabilized base versus a cement stabilized layer. So some lessons that have been learned is that if you don't have good foundation soils, it's going to be hard to get compaction in the stabilized layer. So when I say foundation soils, I'm talking about the soils that are beneath the layer that's to be treated. So in many cases, that's you're treating the layers that, you know, from 10 inches down from the surface all the way down to 14. Any kind of soils or soft subgrades below that could be a problem and should be addressed. In some cases with NDOT, they're actually removing the top 10 inches or so of subgrade material, treating the foundation soils, pushing the 10 inches back on top of the treated soil, and then treating that 10 inches also. So doing almost like a double lift. Also, drainage is very important to keep water from penetrating the underlying foundation soils layer. So if you don't have good drainage or good ditching on your road, when water just sits there, it can end up penetrating into the subgrade and causing failures. So just wanted to show you some case studies of some projects that I've been involved with. This is an example of a job that we did at Hamilton Southeastern High School in Fishers. And make sure that you take time to read the note that scrolls across the bottom. This was a huge money saver for the entire project, where they didn't have to install aqua swirls on the project. Let me see if I can get this going. There's no sound to this one, so I can actually talk during it, but you can see the cement slurry that's been applied right in the center of the screen. The stuff that the compactor is working on has already been mixed. The MS4 for this project stated that since it's over 1 acre, any disturbance of the soil would require the installation of underground water quality structures. So the engineers who worked on this basically found that since they're using FDR, that they were able to eliminate the need for that. And after the treatment and all the fine grading, then it was paved over with, I believe, 2 layers of asphalt, an intermediate layer and a surface layer. So just another example of how, you know, being in the ready mix industry, that job typically, historically, ready mix really wasn't a part of it unless they were doing stuff for the curbs. In this case, we got to be a part of 100% of that surface area, which was really pretty cool. Town of Zionsville, this was a rehab of an existing subdivision where the subdivision roads were getting milled and filled, but after they milled, they realized there's no way that we can possibly do this without, you know, some substantial excavation of some sloppy soils. So what they decided to do was to bring us in to stabilize it with a contractor, and then they went and paved over the top of it. And this job already had curbs that we were able to just work inside the curb and not have to disturb the curbs. Citizens Energy Group has done quite a bit of work with us. Downtown Indianapolis, they have a STEP program where they're actually running pipe down the center of roads. And this process obviously destroyed the road. And so we were able to use FDR to help them achieve their goal of rebuilding the road and not having to spend as much as they would have normally had to. This is a example of what it looked like before, and that's during this placement of the slurry. There it is after the slurry placement, compacted and smooth drum rolled, and there it is after it's paved. And this job actually was given an ACI award for Outstanding Achievement in Concrete for sustainable concrete construction. So that was back in 2013, and there's the project participants there on the right. We've done quite a bit of work at Meijer stores and other retail centers. Here's a Kroger. Done industrial sites. This is a big job out in Plainfield where the asphalt failed and the asphalt was stripped, and then we treated the subgrade and it was repaved. Purdue University, Rossade R lot. Also FDR was done there. Hospitals, more retail, Costco. Some of you may be asking if if you got a really wet subgrade or you got some really wet soils, why would you be using a slurry product to add more liquid and more moisture to a soil that's already too wet? So like I said before, the moisture and the water content in the slurry is really just enough to get the hydration of the cement started. It does love moisture from outside sources, from wet subgrades as well, that continues to help it gain strength. So this video is an example of what I'm talking about. Oh crap. So this was a big box warehouse. Those are popping up all over our city here in Indianapolis area. The contractor elected, we're not going to do any soil modification or soil treatment. We're just going to build the shell and then let it dry out once the shell gets put up. Well, most people realize that that's probably not going to happen on its own. So they use the cement slurry inside the building to stabilize the soil. And you know, there was zero dust during the whole process, but the entire subgrade passed the proof roll 100% with no problems. Here's another before and after example. This is down in Franklin. This was a new roundabout that was put in. That's what the subgrade soils looked like prior to us starting, and that's what they look like after cement slurry treatment, and that's what it looked like after it was paved. This was the longest, one of the longest projects that we've ever done full depth reclamation on. This was 26 lane miles of shoulder. This was on I-74, Crawfordsville, starting in Crawfordsville and heading west. This was one of NDOT's first major FDR projects, and came out with very favorable results. There you can see a core of the product that came out, and almost looked like concrete coming out, but it was actually just recycled asphalt, sub-base stone, and subgrade soils all mixed together to make a very nice rigid base. Worked downtown on the I-65, I-70 Hyperfix project, where the grade of the road had to be lowered so that trucks carrying tall loads wouldn't hit the bridge. In this example, 64,000 square yards of material was treated at 6% cement at a 14-inch depth, and as many as 12,000 square yards were done in a single shift. We got passing DCP tests on that in 24 to 48 hours, which is very typical of most of our projects. And also for rural applications, I'll show you a couple pictures. Tipton County has done some FDR in which their old county roads were reclaimed and treated with cement. There's another picture. Also Johnson County, very successful in their FDR program, and these counties are doing this in-house with their own labor forces and their own equipment. In some cases, they need to rent the stabilizer, but many counties have most of the other equipment needed to do the work in-house. Also, windmill access roads, a very good application for cement, because those loads are extremely heavy and totally destroy county roads. And in many cases, I believe FDR is not recommended, but required, so that the county is not left with a trashy road like this. So they can use cement to solidify the soils and then pave over it. So with that concludes my presentation. We're gonna open it up now for questions. I'll let Larry jump back on here so he can.
Scott, thank you. If anyone's got any questions, Scott's going to be here for a little while. Please ask. Once we wrap this up, I will get this all sewn up into a video, get it on our website and on our YouTube page for people to review. So please visit that page. I'll send out the link with it when it's ready. But please ask whatever questions you need answered.
And also feel free to jot down my email address. Shoot me an email if you'd like to speak, outside of this open forum. I'm happy to answer questions there as well. Wait, unmute everybody.
Click right there.
Hey, Scott, Jake Rankin, Altwitzig Engineering.
Hey, Jake.
How's it going?
Real good.
Hey, quick question. We deal with NDOT a lot on FDR projects, both dry cement, dry LKD, and also slurry mixes. And we've seen that they're trying to get pretty strict on their QC requirements for spread rate on dry application. How have they approached that on the slurry application?
I don't know that they've really differentiated between it, as far as the application rates. I know the application rates for subgrade treatment, I believe, are starting to look more in lines with 5% as the basis for cement rather than 4%. And I can't say that that's the case for every contract, but some of the contracts I've been looking at recently have kind of 5's been the starting point. So for FDR applications, I haven't seen any here recently as far as their spread rate.
In terms of the QC field testing that we're doing out there, a lot of times they've been trying to come up with some ideas on square yard tarps or boxes or something like that we can contain the material in and kind of get a weight on it to make sure that true application rate's being spread. How do you think they would approach that with a slurry?
Well, with the slurry, I would say that would be the wrong way to go about it.
Yeah, no doubt.
Yeah, because what's coming out of our chutes is a mixture of cement and water, right? So what we've always encouraged is for them to collect the batch weights of the load, which since our product is made in a ready mix plant, every single load is scaled. So the cement is scaled. There's a known weight of cement in every single load that comes to the job, and then that amount of cement has to be spread over a specific area in order for you to get the proper application rate.
All that information, like your tickets and whatnot, would be provided to NDOT.
That's right.
Okay.
Yep. Any other questions?
Hey Scott, this is Jeff with Patriot Engineering. I just wondered if you ever experienced soils that were just so bad that your trucks couldn't get through, and
Oh yeah.
If that's the case, how you address that problem?
Yeah. So if that's the case, that's usually known before the job starts. Sometimes the contractor elects to wait until they dry out a little bit on their own. I'm not going to lie to you. In some cases, we've had to have another ready mix, one truck pull out another ready mix truck using a tow strap, or even have it hooked onto a dozer. Those jobs aren't really all that fun, but in some cases, yes, that has happened. And I'm sitting there scratching my head thinking well, how the heck is this going to turn out? And in every case that I've been involved with that, we've had very good success. It ends up getting hard and passing a proof roll. So, if it's so bad to where, we're concerned that our trucks are gonna, just get hung up day in and day out on a big job or something like that, then we would address that with the GC and the earthwork contractor to try to come up with a solution. There's even been jobs where they didn't think we could drive through it, so they did put down dry chemical ahead of time to try to give us some sort of a base in which that we could drive in and out. Or stone, that could work as well. But the nice thing about it is the fact that, you know, you're blending together a multitude of different things. Cement is a universal stabilizer, so it works if there's stone, if there's soil. It doesn't matter what the soil type is in our region anyway. You know, the cement is going to bond them all together. Any
Hey,
other
Scott,
questions?
in one of those images, you showed a picture that they had taken a core through the stabilized material. Did they take that back to the lab and break it like a concrete cylinder?
Yeah, actually that was, you have that data most likely, because I think Alton Witzig was the engineer of record on that job, or the I'm sorry, the testing agency on that job. So that was from I-74. Those broke over 1,000 psi.
Okay, that was the question I was going to ask, is we've seen variation in some of those breaks of field cylinders. I know NDOT's tried to take that into account a little bit on some of their new specifications with trying to reduce the requirement for field strengths relative to lab strengths.
Mm-hmm. Yeah, I mean, obviously compactive effort can vary greatly between what you can do in a lab and what you can do in a field. So the lab is really, you know, kind of your baseline, but I think you can get much tighter compaction in the field, you know, just because the weight of the machines are a lot greater. All right, anybody else?
Hey Scott, this is Kevin Augustino with Patriot. You mentioned doing proctors on these. Do you guys actually do density tests on the material, or is it mainly just proof rolls?
Well, it depends, you know. So for NDOT type work, yes, that's always done. Okay, the proctor test is always performed. For, you know, for like that Kroger job or a Costco, no, that was not performed. The proof roll was the ultimate test method. So
Okay.
because ultimately that's what everybody wants to see pass before the asphalt contractor feels comfortable paving back over it, you know. So they want to see that passing proof roll, and any soft areas that there might be, they can address at that time, but very, very rarely do we ever encounter soft spots.
Okay. And have you had any failing proof rolls? And if you have, how do you address that due to like underlying poor soil conditions?
Yeah, most likely then, you know, it may be a situation where we call a company like yours to come out, evaluate, hey, what's going on here? Maybe a DCP test, you know, shows some stiffness in the top layer, the stabilized layer, and then once it gets through that, we've seen the DCP just kind of like, you know, fall in under its own weight, which is just a dead giveaway that, man, these soils underneath the stabilized are bad, you know. So in that case, one of two things typically happens: either the whole thing gets restabilized, usually going at a deeper depth, and then if we've determined that that's not going to work, then undercutting needs to be performed. But I think those were problems that might have been encountered real early on in the process, and I think the whole engineering community and contractors have gotten smarter about, let's think about those things before we get started. You know, if we've got deep underlying foundation soil problems, let's address them now rather than have to come back, because after you stabilize it the first time, you certainly don't want to have to come back on it. So people have gotten a lot smarter about addressing those issues ahead of time.
Hey Scott, it's Jeff with Patriot again. Do you find that before this happens, a lot of times that they are going in with doing a geotech investigation before that, so that they can identify those deeper soils, so that is not the case? Or has your experience been most of the time they just kind of cross their fingers and see what happens?
Well, I think NDOT's leading the way at doing doing the investigation ahead of time and trying to be proactive about making sure that they don't have deep underlying foundation soil issues. You know, it kind of bugged me a little bit, you know, because some jobs we go to, and these are not NDOT jobs, like private jobs, think, oh, well, this job's getting stabilized. It's the miracle drug. It's, you know, we don't have to worry about how tight we put our lifts in or anything like that, because it's once it, you know, once they stabilize it, it'll all be good. Well, that's, you can always kind of tell the jobs that where the earthwork contractor had that attitude, because, you know, the subgrade soils beneath were probably in pretty bad condition. But most commercial jobs where they're testing each lift of fill getting placed, we don't find that issue, you know, as long as the compaction was there. I have done my fair share of jobs where it's just, hey, let's do it and hope for the best too, where the contractor did not do any planning or any subgrade investigation, and you know, in that case, we always had a lot of success. But you know, that's, I think there is a little bit of risk there if you don't get a geotechnical investigation done ahead of time.
Yeah, I was just thinking that when you guys go out to your job sites and stuff like that, with the cost savings that comes with FDR and things of that nature, that it's, you know, with your background coming from A&W, that, you know, a geotech investigation relatively is cheap, shallower borings and such. So just wondered if on your end, if you would, you know, if you do, like when you go on to the bigger jobs, ask them if they have done those investigations and recommend it, just to help you out and stuff.
Oh yeah, absolutely. I do that. I do recommend it. You know, and then there's a fair amount of jobs where, let's say they were hoping to do none, and proof roll failed, and they said, hey, we gotta stabilize. Let's you know, let's get some stabilization efforts going here on this job, because proof roll and drying efforts failed, and then proof roll efforts failed, and so it's kind of a game day decision. Let's treat it. And typically, you know, you guys are making recommendations on things that have worked really well in the past, depending on the soil type and depth. So in my history, you know, 4 and 5% cement at 14 and 16 inches deep has always taken care of a failed proof roll, as long as you don't have deep underlying soft soil issues. Any other questions?
Scott, I've got one.
Yeah.
How often do you see lime stabilization fail and you have to go in and do this as a second option?
Oh, quite often. I mean, the lime stabilization, I think, is better for drying out the soils to get the soils to compact, you know, on their own. But I certainly don't think it's a long-term solution. It also depends upon the way the lime was installed, you know. So I think, you know, if the lime was exposed to, let's say a building pad was limed, stabilized, and then you brought in all kinds of trucks and cranes to put up tilt wall panels or precast panels, or ready mix trucks to pour foundations or whatever. In some cases, you know, you can see where those have gone bad. But again, that also depends upon, you know, the weather that the lime was exposed to, and if it was properly installed or not.
Any more questions? Well, I think that's it, Scott. I want to thank you for joining us today, and I'd like to welcome you back in the future to do more. And again, we'll make this a recording and we'll get PDHs out here in the next few days. Thank you very much.